Now, the steps to finding the inverse of a function. First off, we're going to graph it to see if it exists. If it exists, then we're going to go on to the other steps. What we're going to do, instead of writing f of x, we're going to write y, just to make life easier. Then we're going to flip the x and y's around, because that's where we're going to find the inverse. Then we're going to get y by itself, and then we're going to write inverse. So your notation for inverse is f to the negative 1x. That's what our notation for inverse is. And then we're going to state the restrictions we have. So maybe we want to start here by looking at the domain and range. Let's do a couple problems together. Let's take a look at example 3 here. So on example 3, I've got this rational function. First thing I'm going to do, I think since we haven't dealt with too many rational functions, I'm going to use my graphing calculator, my Desmos calculator. I'm going to graph this function, or I'm going to graph this relation, I should say, to see it's an inverse, to see if it has an inverse. So we'll go back here, and I'll start here, and I'm going to say f of x equals to, and we're going to go x minus 1. Now, to get something in the parentheses, or in the numerator only, I like to use parentheses. So I'll go x minus 1, and I'll divide that by x plus 2. And there, I can see if it passes the horizontal line test. If I draw a horizontal line, it'll cross it once. So it does have an inverse. So now, before I go on, let's state the domain and range of my function. So my domain, I can have anything except negative 2. So my domain is going to be from negative infinity to negative 2, and from negative 2 to positive infinity. My range, remember in a rational function, we look at our coefficients, so my range is be anything except 1. So my range is going to go from negative infinity to 1, and then from 1 to positive infinity. Now, let's find the domain, or let's find the inverse algebraically. So instead of writing f of x, I'm going to write y. So I'm going to say y equals x minus 1 all over x plus 2. Now, to find the inverse, we flip the x's and y's around. So I'm going to say x equals y minus 1 all over y plus 2. Now, what I want to do is I want to get my x's and I want to solve this equation for y. So to solve this equation for y, I think what I'll do is I'll multiply both sides by y plus 2. Then I'll get xy plus 2x equals y minus 1. Now let's get all the y's on the same side and everything else on the opposite side. So I think I'm going to subtract 2x from both sides. At the same time, I'll subtract y from both sides. So then I'm going to get xy. Whoa! Sorry about that. I'm going to get xy. I wanted a different color, but there we go. So I'm going to get xy minus y equals negative 1 minus 2x. Now I want to get y by itself, so let's factor that y out. So I'm going to get y times x minus 1 equals negative 1 minus 2x. Then I will divide both sides by x minus 1 to get y by itself. And then so y equals negative 1 minus 2x all over x minus 1. So then my inverse, f inverse of x, is going to be negative 1 minus 2x all over x minus 1. Now notice my range of this, my domain of my inverse, x cannot equal 1, can it? So I'm going to say I'm going to restrict my domain to negative infinity to 1 in union with 1 to positive infinity. Notice the domain of my inverse is the same as the range of my function, because we're flipping the x and y's around. So that should not be anything new for us. Now, I want you to do example 4 by yourself, and then in the next video, I'll explain how to do example 4.